Hello, everybody. Take your hand off the mouse. Quit scrolling. Today we're going to talk about program scan as far as how the Control Logics and Compact Logics PLC do it. Because a lot of you were surprised last week about how the always false instruction affected the outcome of the PLC. Now, if you didn't watch that, don't worry. I'm going to go through the whole thing here in a little bit. But for the most part, we were doing this test program right here. And yes, I know this is very basic logic, but this was our old logic and this was our new logic. And mainly used to the green button would turn on the green light, and we were making it where the yellow button would turn on the green light. And the main purpose of this was to explain that the always false instruction is truly always false. It does not disable the rung. And a lot of you were surprised when I hit the yellow button that occasionally, and it's not going to do it now that I'm staring. Come on now. There we go. Occasionally the light will flicker. So we are getting an unpredictable outcome. And that's what we're going to talk about today, is why this light flickered instead of being 100% on or 100% off. Now, before we do that, I do want to address two of the other comments. Because one, I appreciate all the comments and all the questions. In fact, I quit counting at 117. So 117 of you, I really appreciate you reaching out and asking questions about this. And the main really legitimate question was, why did my lights flicker? Now, there were two variations of that question, though. First of all, quite a few of you said I should not be talking about the AFI instruction because it's a bad instruction. And I just want to ask you, are there any other instructions that we shouldn't talk about? Because we're going to run into all of them. And just because I talk about an instruction doesn't mean I'm endorsing it for presidency or something. So we need to learn about them, whether we like them or not. For a good example, the SQI and SQO sequence instructions. I'm not a fan of those instructions. And I have a video where I say I'm not a fan of those instructions. Now, immediately after that, I show you how those instructions work and also give you 8 alternative ways to do machine sequencing. So I believe we do need to talk about this and we do need to understand it. Now, there was another camp that really I'm probably not going to be able to convert, but I do feel I need to address, is a lot of you said that I was wrong, that the always false instruction does in fact disable a rung, and it's not that it makes it false. And the reason that I got the unpredictable outcome was because I used a duplicate destructive bit, or I used the green light output twice, and that confuses the PLC. Guys, PLCs don't get confused. They know exactly what to do. And I did not break a rule. So let's talk about rules in Studio 5000. So if I bring down a new rung, and I put a go look for a 1, and I'm just going to name this an input without an output. And I've declared that, yes, I'm not going to put an input in this rung, no matter what Studio says. And I create new, have a red X still. Now, the reason I have a red X is because I have broken a rule here. I have to have an output instruction in this side. Now, if I take this green light and I drag it down here, now I have triplicate destructive bits. It's ready to go. It is going to say that we're good. And so this is not breaking a rule to have multiple outputs. Now, it may be a bad practice, but it also may not be. And it is something we're going to run into. So this is a program that the technicians that come to our training class work with, and it's meant to mimic exactly the situations you'll see in the field. And if I hit the verify button here and I bring my box up, then you see I have 22 warnings. And notice there are a lot of duplicate destructive bits in here. And it's a warning that they are here, not an error. I did not break a rule. And these are legit use cases of seeing duplicate destructive bits. Also, you're going to get warnings about AFIs. It does not mean that they're not able to be used. It just means that, hey, you might want to look at this. And you're also going to get warnings of shorted branches. Whoops. And these are not errors. They are simply warnings. So just because we maybe shouldn't do something doesn't mean that we won't run into it. And so I want us to understand why the light flickered, not say we just should not have duplicate destructive bits. And I'm gonna preemptively also make a comment because I know a lot of you getting those fingers ready. You're like, I know how to fix this. Is a lot of people say, well, this is why you should map your IO in one spot. That way you get a predictable outcome. Now, I am not arguing that you should not have one spot to map your inputs. I don't do it. That's a personal preference. What I am going to say is wrong is if you map your IO to fix unpredictable situations like this. Because if you do that, when someone goes to troubleshoot the machine, they're still going to end up in your unpredictable code. Now, the big thing that really confused people on this is how the PLC scans, because we have been taught that PLCs scan their inputs, they run their program, then they update their outputs in that order. And that's what I call it the traditional scan cycle. Now, when I say traditional, that doesn't mean old. It just means it's one way the scan works. Also, we call this the synchronous scan. So if we look in, let's see, did I open that student guide? I thought I did. Where's the student guide at? Here we go. So this is part of the guide that when you come to my training you get. And this is the Micro 800, Micrologix, and Slick 500, many other PLC scan cycle. So it's going to read its inputs and update the data table. It's going to run its program not based on these wires over here, but based on these data table values. And then it's going to update its outputs. And here's where the really bad saying, and if many of you watch my videos, you know it really irritates me. We say the last rung wins. The last rung does not win. The end statement will win in this situation. And yeah, I probably should do another video on that because I get the feeling that'll be the next thing somebody says. And well, yeah, the last rung should have won. And that's what you think here. So if we go back to our program and we look, since I have this AFI here, let me go and delete this out. According to the last rung wins, the green light should always be off. And this is why I love this one. And this is one of the exercises we do in the training week, because the last rung kind of wins, because if we stare at it, it's when you're staring at it, it just never seems to happen. Occasionally, come on now. Man, here's where video editing comes in handy because yeah, right now, and we're going to talk about this timing of why this is happening. All right, well, you saw it earlier. The light was flickering. Why is the light not flickering now? Oh, because I'm pressing the wrong button. That's why. If I press the right button, then occasionally the green light flickers. So the last rung kind of wins, almost wins 90% of the time. The last rung does not win. And I see this in way too many textbooks. I see this in way too many explanations, is the last rung does not win. Now let's talk about the scan cycle. Let's get back to that though. So if we look back, this is the traditional, the synchronous, or the Micro 800, Micrologix, and Slick 500 scan cycle. But this is actually how the ControlLogix and CompactLogix scans. It's continuous task, which is what most of you, when you're starting out, write all your program in. We could talk another day about which task what should be in. But this is where most of your programs are, is it's going to run as fast as it can. And so typically it's going to be running your program. And then it's going to go up here and it's going to do a little bit of overhead that honestly we really don't even usually talk about. And then it's going to come back around and do it again. And then our inputs are actually updated asynchronously or not in sync with this continuous task based on what we call an RPI. And our outputs are also updated based on an RPI. And this RPI will be different for every module. And this is what's making what we feel is an erratic outcome happen. So if we go back over to our Studio 5000, then let's go and see what that RPI is to start with. So we're going to go to properties of our embedded discrete IO because that's where our buttons and our lights are coming from. And then we're going to go to the connection tab. And so right here, its requested packet interval, or how often it's reading its inputs and updating its outputs, is 20 milliseconds. Now, if we go to our program, this is our main program that's actually spinning around really fast, and we go to its properties and go to its monitor tab. I'm just going to reset the max so we can see. We're running a high of 30, going down to 8, but also as we reset it, notice it's bouncing occasionally. So that RPI, along with our continuous task and that little bit of variability, is what's given us what appears to be an erratic, oops, if I hit the right button, what appears to be an erratic issue. All right, now I'm going to try something, and honestly, I've never tried this before today, so I'm not sure if it's going to work, but we are going to try to make an exercise where we can really understand this periodic task, because we're going to slow it down. And I want to show you why we're doing this. Is right now, with our if I can find the right button to hit, with our very small program, because really we have these two rungs, it's spending actually most of its time in its overhead task. And that's why most of the time the green light is off, because the RPI is going, I mean, without the RPI, just the continuous task, it's going to do rung 0. And when I'm hitting the yellow button, this is going to write a 1 to the green light. Let me hold my finger on that, that way you can see that. So right now, rung 0 is writing a 1 to the green light. And then with the always false instruction, directly beneath it, we are writing a 0 to the green light. So the only time that the green light is actually going to show on our PLC is when the RPI happens to hit between rung 0 and rung 1. Now here's where the continuous task, that little bit of overhead step, is coming in and kind of causing us more erratic issues. Is if we go back and look here, we had this overhead, and I really rarely even mention it because it's fairly insignificant on any large program, but right now we only have a 2-line program. So this is where the PLC services communications and does a lot of things that honestly we never even worry about. So we're going to try to slow this program down, and we're going to do it with a jump and label, just like we did in the last to actually disable the rung. Now, I feel like I need to say this before, because I know somebody's going to hammer me on it. I really racked my brain this morning. Outside of this exercise, I cannot think of a single reason why you would ever do what we're getting ready to do. But we're going to try to add some fluff into this so that we can slow down and see what this light's actually doing. So let's go and look at a couple areas that are going to be trouble. Is the first thing I'm going to do, let's see, do I want to fault this PLC or do I want us not to do that? Actually, yeah, I will fault it at the end if y'all put it in the chat if you really think it would help you out. But for now, what we're going to do is first, we're going to right-click our main task and go to Properties. And we're going to go to Configuration. And we have this watchdog timer here. And I'm going to slow this scan up so that we can really interpret what this light is doing. So the first thing I'm going to do is I'm going to make this watchdog 5,000, and that's going to be 5 seconds. And then we are going to add a rung right underneath where we're writing a 1 to the green light. So we're bringing a rung down. And in this one, we're going to go over to our program control, and I'm going to bring down a label. This is the same thing we did in the previous one. And I'm going to bring down another rung. And in this one, we're going to put a jump. Now, I know a lot of you probably already like, hey, Tim, I think you dropped them in there backwards. Well, no, I didn't drop these in backwards. I am going to try to make this thing jump kind of right in this one little area for a little bit of time. So now we're going to go over to our favorites tab. And we're going to bring down a go look for a 1. I'm sorry. We're going to bring down a go look for a 0. Examine off. And we're going to go to the timer counter and bring down a TON. And I'm going to call this my top timer. And I'm going to right click it and new. and we're going to create, and I'm going to make its preset and its accumulated value 0 for now, because we're going to slowly talk through this if it even works. And then in front of it, we're going to go look at the top timer.dn. And this is the sample rate program that we've done before in videos. And if you need a link to that, just put it in the chat or in the comments if you're watching this video later, and I'll make an end screen at the end of this video that has it in it. All right, and so if I jump in label, we need to jump to the label. So I'm going to call this my top slowdown. And we're going to jump to the top slowdown. Now, remember, we have to have output instructions. So in this case, I have broken a rule, not with this duplicate destructive bit. So we're going to go back over to our program control, and we're going to bring down an NOP, known operation. And so, yeah, we used both of these instructions minus the sample timer in the last video. And now I'm going to copy those two. I'm going to highlight both rungs, right click, copy, and I'm going to paste them at the bottom. And I'm going to rename this to my bottom timer. And we're going to right click it, new, create. And I'm going to make this my bottom timer. And then I'm going to make my label the bottom slowdown. And there we go. All right, so I'm just going to go ahead and put this in our PLC, and we'll talk out what's happening here with 0 preset to start with. And notice it pretty much is going to work exactly the same. We press our yellow button, since now I remember it is the yellow, and we're going to see this erratic flashing of the lights. Now, that's because right now everything is happening really fast. And so that's what I hope to do with these timers is slow everything down. And so if we go back here, then if we look at this, let's just talk through these two new rungs right here. So we have a label, which is really just a place that a jump is going to go to, and we have a no operation NOP, and this literally means no operation. So just a place marker and a place marker. Then we're going to go to the sample rate. And this goes and looks for a 0 at top timer done. And initially it's going to see a 0. So this is going to be true. And that's going to enable the TON. And this is also going to jump to right here. Now, since this is a 0 preset, this done bit, the second time will be a 1, which is going to make this false. And it's going to go around again. Now, we have videos on this, so I'm not going to get any further in the weeds of this because really we want to see what happens when we start putting values in this preset. So now I'm going to right click my main program and I'm going to go to properties, and I'm going to go back to that monitor tab because right now we have a very minute scan time. In fact, I didn't really mention it. This is a microsecond, this US right here. And so this is a super small amount of time. Now, our preset and our timer is actually in milliseconds. So watch what happens to this number right here when I put a value in the preset. So I'm going to put 10, which is a value of 10 milliseconds. And the moment I hit enter, oh, you know, I do have to stop with a little bit of relief because, yeah, I really hadn't tried this. It did work. So, yeah, the scary part about doing things live. But all right, so now we've slowed this time down. And if I go down to this bottom one, we're going to slow this one down. Now, notice I put 10 milliseconds here and 10 milliseconds here, and I've made almost a 20 millisecond scan time, which if we go back to our embedded discrete I/O and the connection tab is almost the same. And I got to tell you, I'm not 100% sure, but I believe it will be very unpredictable whether when I press the yellow button, this is going to be on or off because we're so close to the RPI. So I'm going to press it. Okay. It did not appear to come on. But right now we're nearly the same between our scan time and our RPI. So now what I want to do is I want to separate those two. I want to get them way out of sync. And I believe to do this, and again, this is halfway a guess. It may take me a couple times to figure this out. That if I put 15 here, that's going to get us to 23 milliseconds. And just to keep them even, I'm going to put 15 here. And I believe now, and I don't know with the speed whether this will be the LED be able to catch up, but this should make us on off quite a bit. All right, and there we go. So now our light appears to be consistently flickering. Now, it was consistent before, but it was kind of out of balance. Takes a little bit for the light to pick up, and even in this case, since we're going on video, it takes a second for even the, what do they call it, the FPS to actually pick it up. So now let's slow it down even more. So first, can I change the RPO while we're in run? We're going to find out. So I'm going to go back to my embedded discrete IO. And yeah, I believe I can change my RPI while the machine is running. So I'm going to make the RPI 1 second. So I'm going to put 1,000. I'm going to put 750 in. I'm going to put 3/4 of a second because right here it says 1 millisecond to 750 milliseconds. So 750. And then we're going to go back to our main routine. And this should allow me to get this thing super slow. Now, honestly, I'm not sure. And I bet you in the chat are probably like already shouting out exactly what we need, but I'm not sure if I want to put 375 here or 750 here. I'm going to put 750 and find out. I think this is going to make it flash on and off at a rate of 3/4 seconds on, 3/4 seconds off. There we go. So now, because we've slowed all this down, it's doing the exact same thing it was doing last week, but we've made it where we can really follow what's going on. So first, our scan time. In fact, we flip over. In fact, yeah, I can switch over to that screen. Is our scan time is now right at 140 milliseconds. And if we go ahead and click OK, let's talk about what exactly is happening, because it'll be easier to see now. Is rung 0, whether it's true or false, it's going to go update this output. All right, then we have a label, and we have the no operation. Only this time, because now we can actually see the values happening also, is if the top timer is not done, if it has a 0 in it, then this is going to be true. And along with being true, it's going to jump right here, go to the NOP, come right back down here. And so you can see it. We've slowed down this scan enough now that you can actually see this going. And so we're making this thing stay right here for 3/4 of a second. And then we have our always false instruction, and we have our green light. And then we're doing the same thing. So we're making it stick at the bottom for that long. And let's talk about what's happening then. So I press the yellow button. That is making rung 0 true. And a true output energized goes and writes a 1. And whether we believe it or not, this at this moment in the program is always going to be a 1. And then we have that dwell thing. And so it's getting stuck here pretty much for 750 milliseconds. And then it's going on to this one. And we have our always false instruction. And whether we believe it or not, in fact, because we have the green button, it doesn't matter. I'm not pressing the green button. This instruction goes and looks for a 1. It's seeing a 0, so it's going to be false, even if you don't believe me that the AFI is false. And that is always writing a 0 right here. And then we have that same dwell thing happen on the bottom. That way we've slowed this whole scan down. And that's why we can see 3/4 of a second on, 3/4 of a second off. And this cycle is now one single scan. Now, I'm going to try to make one more attempt at you that really thought I was wrong about the AFI, and it did in fact disable a rung. Because if it simply disabled the rung, then I should be able to take this green light out. And now when I press the yellow button, if it was truly only disabling the wrong, it should stay green all the time. But when I press it, it's going to do exactly the same thing. So always false instruction does not disable it wrong. It always makes it false. All right. Now I'm going to catch up on the chat over here because yeah, I also have to apologize. Yeah, I did not have my chat interface open last week. So let's see. Andy Electrical. Yes, you were the first one on. I really appreciate it. Nice to see you. Deepak from India. Great to see you. Terminator, Lexington, Kentucky. Great to see you. And if you have questions about this or about any scan related thing or anything at all, go ahead and put in the comments because I get a feeling this is going to continue. If it's like last week's, then yeah, there are enough questions. We may just hop on and continue building on this every week. But we got Tony from Kenya. Good to see you. Mark, New Jersey. Oh, Anthony, you want to make that's right. I was going to show you the fault. So yeah, I'm going to do the watchdog fault next. We might as well do that. See, Emmanuel, great to see you. Hey, Mom, good to see you. Mike, I'm in California en route to replace a 1769 IF-16. Oh boy, that can be fun. Hey, James, it's great to have you on. Okay, let's talk about that watchdog. Yeah, because I did forget about it. So early on, the first thing I had you do, if you're following along, I had you do it. The first thing I did was I increased this watchdog because I knew it was going to be an issue. But all right, let's reset this back and we'll put the watchdog and everything back where it was. So first thing I'm going to do, I need to do this in the right order. That way we can talk through what's going to happen. I'm going to change my RPI back to 20 milliseconds. And then I am going, make sure I get this in the right order. Now I'm going to change, let's put these at 0. This gets us back where we were before we deal with the watchdog. All right, now I'll go back to, actually, let's look at the main program first to make sure that it should be a ridiculously small amount of time now. And it is, we're back down around 10 microseconds. And now I'll put the watchdog back like it was. I'll put it back at 500. And let's open the main program that we can see this live as it happens. And right now our scan time is 10 milliseconds. And I'm only going to worry about the top timer. I think you guys understand what's going on here now. Is I am going to put 100 in. And now our scan time is nearly 100 milliseconds. And can I have both of those open at the same time so I can bounce back and forth? Yes, I can. I don't know if it'll let me. Am I going to be able to click on there? Yeah, look at there. All right, so we have a configuration. Oops, I must not have hit the apply button on that one. There we go. Now we have a 500 millisecond watchdog, and we have a scan time of 100 milliseconds. Actually, man, I never thought about this. This is a great way to exercise a watchdog timer. So now I'm going to put it at 400 just so we can bump up against it. And we see this go to 370 something. We seem really happy. All right, and now I'm going to put 500 in. And actually, it's kind of interesting. I guess we are right on the edge where this probably 500 may or may not fault it exactly. Put 500 in. All right, and actually, no, we're hanging in there right at 406. Oh, there we go. Okay, so occasionally it was bouncing up. So let's talk. Well, yeah, let's just talk to this. Let's not assume we know this. Is we're going to go and find what our fault is. And the easiest way to get there is go communications and then go to faults. Do not clear your faults without knowing what they are. I know we're in a hurry. I know production costs a lot of money. But the absolute worst thing that can happen is you clear this fault and it not come back because you're going to get called back in at 2 in the morning. And yeah, production will have been down for hours waiting on you to get there. So it says type 6, watchdog fault, code 01, task watchdog expired. May have been caused by an infinite loop, complex program, or higher priority task. And really, I should do something on the task priority sometime. But what I love about Studio 5000 is it tells you exactly where. Task, main routine. So something in this main routine got this thing hung up. And we already know it's this TON right here. But so yeah, we look over here, and I should reset the max before I did that. I didn't think about that. Let's do that again. Yeah, we can do this again. So I'm going to put this back at 300. That way we won't fault. And we are now going to go over here. We're going to clear our majors. And we're going to put it back into run mode. And we're back going. And we got 300 here. I don't know if it actually ever shows it though. So let's just go up to 400. Well, that gets us up. I don't think it is. It's kind of interesting. I guess the execution time. Oh, but we have the task overhead here. Ah, okay. I do understand what is happening now. There is a little bit there, a little bit overhead. So we'll never actually see this go to 500 because really 480 probably does fault this. In fact, I bet I can make it fault to that. Maybe. I don't know how much the overhead time really is in this processor. Maybe 490. Or maybe we'll just go for the 500, but we put it on 500, we know that, yeah, we're never actually going to see this hit that, but we do know now it is going to fall. So yeah, that's what your watchdog does is it looks and says, hey, is this program taking too long to run? Let's see, where are we at here? Hey, Mary Bruce. Good to see you. Mary Bruce is now 2 doors down. You didn't know it, but we've actually been separated for like 3 years where we opened the training center. We're finally getting our trainer production moved down here, which is really exciting. Hey, William, very good to see you from Indiana. All right, Anthony, it was good to see you. Really, if nobody has any other questions, really, that's the big thing I wanted to hop on here for is to talk about what happened last week and really just hopefully get some of you to see, okay, well, I hope there's 3 takeaways from this. I hope you do understand how program scan works. I hope you will begin to agree with me that we shouldn't just say, well, thou shalt not use an AFI. No, we need to understand the AFI. And in this case, yeah, it does make an instruction false. It does not disable the wrong. And yeah, while duplicate destructive bits may be bad, we may need to understand them because you may run into one of them out in the field. So thanks for hopping on. That's all I have for today. So have